Hello again, and welcome back to stage 2 at Data Center Live London. For this session, please keep your questions coming for our speaker, and I'll include as many as I can throughout this session. Next up, we have the Edge Computing Forum, and my guest here is Jon Eaves, founder and CEO at Edge Centers. So, hi, Jon.
Good morning. How are you?
Yeah, not bad. Thank you. Sorry, I definitely got the name right that time, didn't I? I said Edge Data Center before, but...
Edge Centers. Yeah, that's correct.
Perfect. Okay. So this session is going to kind of be about, from my perspective, a lot about people who don't know much about edge computing or have kind of just started to learn about it. But first, I thought it might be worth just defining what edge computing actually is.
So I think really to define edge computing, we need to really define what the edge. So the edge is really the last device. So your phone at the moment is the true edge. It's where the data is sourced. So when you're using an application on your phone, the application on your phone generally is drawing data for that particular app from another location. Now, you know, as you're looking at large applications that draw, such as Netflix, if you're streaming on your phone, you'll pick it up from a Netflix port. Now, the idea of edge computing is you store that data and that compute closer to the end user. So what you want to be able to do is, so the end user isn't going all the way from hypothetically Manchester to London to get the data. They're going from Manchester to a location in Manchester or you know, Leeds to Leeds, etc., where they can pull that. So it's primarily about edge computing is to reduce the latency and bandwidth requirements by processing the data in proximity to where it's generated. So the closer the data is to the source, the less latency. It also means then you're reducing the backhaul of data throughout the internet in the particular country, which obviously also minimizes your costing.
Yeah, sure. So it's kind of the driving force behind the demand that we have for data at the moment, especially in the digital era. And I wonder if you could kind of explain a little bit about some of the issues that edge computing has solved. Obviously, one there is latency, but maybe you could talk a bit about that.
Well, I think so. We refer to this now, and it's a terrible term. We call it the chicken and the edge. In that, firstly, to solve the edge computing problem, to put the edge compute closer to the user, you firstly need to have the infrastructure, and that's what in a lot of the countries we're working in and developing our platform in, they don't exist. So, as an example, in Thailand, there's 30 data centers. They're all in Bangkok. We put our first one in a town called Chiang Mai, which is 9 hours by road from Thailand, and there's no data centers there. So that is true edge because the infrastructure is there closer to the users, and then obviously supporting the compute for those then facilities. The biggest challenge is really, besides the infrastructure, is building a data center without connectivity is just an island. So firstly, you then got to solve the infrastructure, then you need to solve connectivity. And if your data center is just connected back to, say, Bangkok, or if it was in Manchester, it was connected to London, you're backhauling all of the information, even though the compute is happening local, what you haven't solved is that data still needs to be backhauled to a central campus. So the idea of the edge is you'll have multiple locations. So the edge isn't one, the edge is many. It's effectively a mesh network of facilities and obviously edge compute that can scale and move around a zone. So you're not just talking about a single cloud instance, you have multiple active instances across 3 or 4 locations. And as an example, when you're on your phone now, and normally you would connect to a tower, and as you're driving, the phone would then connect to the next tower. When it's successfully connected to the tower, it would let go of the last tower and look for the next one. So you're continuously maintaining that call. Now we've virtualized the calls into containers. We can effectively have 3 towers live simultaneously, and the mobile instance moves virtually as a containerized solution. So as you're driving, there's always 3 instances live. So therefore, you'll get a lot better service as a phone than you would as a normal cell connection. So the edge and the edge compute is changing the smaller parts of our industry. As again, going back to 5G is one of the biggest use cases, but it's also bringing the challenges of how do we get these infrastructure and these locations to be active all over a country simultaneously, which is the hard part.
Sure. And just kind of following that then, obviously, with the infrastructure and connectivity we have now, what are kind of the challenges that we're facing at the moment in terms of implementing more architecture?
More locations, really. I mean, if you look at we're in what I would still call the hyperscaler boom. And obviously the hyperscalers themselves are consuming most of the facilities built globally. To see a campus now, of 10 megawatts 3 years ago was huge. To see a campus now of 100 megawatts is normal. And as we were looking, I was watching the Scala message before whilst you were on the break. They're talking about 600 megawatts now. So there is still this hyperscale boom. So edge is still relevant and it's still current, but it's still in its infancy. I mean, I've been in the edge or at the edge now for 3 years, 2 years in my own company. And I still don't think we're at an edge point, at a transition between. So whilst the hyperscalers still grow, it's a good opportunity for us to then acquire new markets and move into new markets to prepare it. But then as we will get to, the edge product needs to be ready as well. And that's still undefined. So the edge, it's a great word. A lot of companies are rebranding to be edge, I think, to remain relevant. But the issue is going to be having the facilities and the interconnection between facilities. Again, edge isn't one, it's many. So if you've just got one data center in a regional area, that's not really going to work for you as an edge because you need multiple. And as always with data centers, you still need redundancy.
Sure. So what, in terms of edge computing and cloud computing, what are kind of the benefits of edge over cloud?
So it's a very good question. I think, so cloud is a technology that's used. And, if you look at edge, previously there was a term called fog computing, and edge is very much a transition. So fog was the variation of cloud that obviously moved. So we have cloud and edge, and they are actually, I believe, conjoined. So all edge instances at some point will, and again, if you think of the edge as a filter, so rather than transferring terabytes of data to and from a facility that's a hyperscale, the edge is used, and the edge computing at the edge is used to filter that data, to correlate it into more human readable, and then only the relevant information is moved to the big cloud or the hyperscaler. So the edge is a necessity, as is the cloud a necessity, but the cloud does live at the edge. We have our own customers running cloud systems, their own private hybrid cloud at the edge, but it's also connecting back to a hyperscaler cloud. So the reasons is obviously latency. Customers don't want to be buying large backhaul links. Now, even though prices are dropping, they'd still prefer to be close. Bandwidth optimization, because they don't have big backhaul now, their costs are less. Privacy and security, because they can now access their own equipment locally. It doesn't have to be necessarily, again, Chiang Mai to Bangkok, 9 hours drive. It's in a secure facility that still meets the standards and requirements of a normal data center. And it also meets all of their security and certification needs. And then scalability, that, by having the option of both, they can decide whether they build at the edge or whether they build at the cloud, or having both in a hybrid model seems to be working very well so far.
Sure. And I guess there's a point there as well in terms of global expansion of data center operations. It kind of, edge kind of, I imagine, enables a lot more international national expansion for companies.
Yeah, and we started in Australia, we moved into Asia, and now obviously we've expanded into the US. I'm currently back in Australia. We just closed an acquisition today, and then I fly back to America tomorrow, and we've closed 3 acquisitions there this month. So it's a wonderful opportunistic time to be in an industry, especially where it isn't defined. There is something I'm learning about the edge and the business I'm in every day. And also learning what the customer's definition is of edge. I think, it really is a gray subject at the moment as to what it really means. And I think that's the best part about being in this industry, is we're helping shape and define what it will become by being early adopters.
Of course, yeah. And I want to kind of touch upon this point of obviously 5G is quite critical at the moment. But how does edge computing almost enable the adoption of 5G, or is it kind of one kind of supports the other in a way?
I think 5G is 5G and 6G, and 6G is obviously under development and operational in certain countries. 5G changes the paradigm on what we do on a mobile device. So it's, I mean, if you look at 3G to 4G, that was a huge shift for us. 4G to 5G is a massive shift in speed, but not in user experience. 3G to 4G was epic. Live streaming games, playing Call of Duty, watching Netflix, all of those day-to-day things. And now, 4G and 5G has leveled in Asia. Most people now have two devices. They have one they're playing a game on and one they're watching YouTube on simultaneously. So we've now got this increase of adoption of dual viewing, which I think is phenomenal, that they're able to multitask, watch something on YouTube whilst playing a game or whilst working. So the 5G requirement, again, because of the short span throw of the antenna, means that you need a lot more antennas, a lot more fiber, and therefore a lot more facilities to, cover this low latency, high bandwidth that 5G offers. So the distributed architecture, the amount of antennas behind it, the amount of dark fiber, just the all-round, speed increase of 400% means everything has to go upwards 400% to support it. So in some countries have adopted, we're in Malaysia, hadn't even started yet. We go to Vietnam and it's everywhere. Australia, it's in all major capitals now. In the US, it is absolutely everywhere. And it's been very successful. So the 5G aspect is good, but I don't think it's something that affects the edge yet. I think, if you looked at the early, if you went back to, the major edge computing use cases, and you're talking about IoT, automation, smart cities, autonomous vehicles, 5G was one of those use cases, but 5G is just a parallel technology that needs an edge style facility. But as we've seen already, 5G has existed quite happily without the edge being a supporting function, because the telecommunication services themselves have so many locations and so many towers. They were able to do that quite successfully.
Sure. And obviously you mentioned there autonomous vehicles. I think that's one of the key conversations right now as well, particularly in e-mobility. I feel like that's quite a good one to touch on. In terms of, obviously, because cars are becoming part of what I would consider, the digital ecosystem. They're now IoT devices, effectively. Correct me if I'm wrong, but how does that kind of affect how edge computing operates? I suppose nationally and internationally, if cars are moving a lot quicker than we would with our devices, what effect does that have?
I think so, and as we had this on a panel discussion at a location, an autonomous vehicle is a data center. I think that's the easiest way of just describing it. So a Tesla has more capability and more tracking and logging than most data centers themselves do. So the autonomous vehicles, I think it refers to, are more drones, farm agri-tech, mining equipment. We've now got mining trucks that run autonomously. I can't ever see a human passenger vehicle that can travel at velocities more than 30 kilometers now ever being reliant upon an edge facility. With Elon Musk having Starlink, which connects the cars now, that they are just literally doing the metrics go up and down. The car itself operates quite happily without. Because if you were to lose a data center and your car was operating at 100 kilometers an hour, just because of hypothetically a major snowstorm or blizzard like there was in Austin 2 years ago, which took out some facilities and shut the city down, that would just be, deadly. So I think it's the definition of what an autonomous vehicle is, and that really is more unmanned objects that currently are available, but would be more prevalent to requiring a connection to an edge facility to obviously generate the movement, the logging, the tracking, the telemetrics, etc.
So you don't think that with a significantly higher amount of edge facilities that would be a viable solution?
I personally would never buy one of those cars. That's all I'll say.
Or wouldn't buy electric or wouldn't buy autonomous?
I wouldn't buy autonomous, not if it needs a data center. And I trust my own imperatively, but yeah, I'm not that game yet.
Of course, yeah. And I just want to reiterate to our audience as well that we do have the option, if you want to ask any questions to Jon. I'm going to continue anyway, but you mentioned there about mining, and I'm curious to know a bit more about kind of the industrial applications and kind of how industries like mining, construction, etc., have evolved as a result of edge computing.
So the first real application of private 5G or LTE was obviously at mine sites where communications around a mine site can't be run by normal telecommunications companies, because when you go underground, you're subterranean. But once you're subterranean, then you lose all connections to obviously the main facilities. Most mines will have 2 on-site data centers which run the 5G and backup 5G links, and then they'll have a mesh network of nodes in between that operate as well as the compute. And again, as an example, they'll have drones that go into the mines. They do gas checking. They also do LiDAR of the area, and then that's transmitted back obviously to the surface and it's logged. So the mine is probably the best use case of what an edge smart city would look like. So if you look at a mine and you refer it as a smart city, all of the IoT data processing, the analytics, they generate phenomenal amounts of data, from seismic through to geographical samples to layers to aging. That it's the amount of sensors, metrics, vehicles, logging, safety, cameras that operate to keep a mine safe and secure is exponential and equal to that of a smart city. So mines, I think, are the very first real edge campuses that have existed for years and are only getting smarter. You look at the technology on a mine now, it's just been exponential to compare to what it was, say, 5 years ago.
I guess that will kind of be echoed through smart cities as well. A lot of, especially an example you gave was London earlier. I imagine that kind of evolving in terms of how they would operate in London and other major cities.
Yeah, I mean, a lot of these new smart bulbs, I think just the innovation of something simple. So you've got obviously the legacy lampposts. The legacy lampposts are now being upgraded to LED lampposts. And now the legacy LED lampposts are being re-upgraded or alongside the legacy lamppost ones with smart bulbs with IoT sensors in them. So now you're starting to have IoT repeaters all the way through an entire district, all based from lampposts powered by the actual light itself. And then there's enough to move data privately around a LoRaWAN network connected to the city's council's own network. So it's a very clever way of moving certain information and getting certain markers back from that as well as they're using.
Sure. I'm going to jump to, we've got a question from the audience here. I believe this kind of relates to sustainability. So if you're off grid, are you using batteries for non-sunshine hours? And if so, how do you manage the economics of having sufficient power storage?
So we have solar, which obviously runs the 8 hours. So in Australia, we get generally 8 hours. So my solar day runs from about 6:15 in the morning, and this is Grafton, to about, I'll call it 3:15 in the afternoon. That's normally a solar day. Then for each inverter, and there's 3 inverters, so you've got 3 banks of 36 kilowatts. So you've got 72 kilowatts and then a backup set. So you're N+1. On that, you have per inverter string, you have 80 kilowatt hours of batteries. So 10 kilowatt hour batteries. That has sufficient power to support the load throughout the off period. and we have enough to last just over 24 hours. So we have had 2 or 3 instances at, say, Grafton, where utility has come on, and that's just because we've had weeks of very inclement weather and the battery system wasn't able to charge fully. We bought a software company last year that had cloud monitoring. Well, we bought the software company because it monitored snow, and it would advise quite accurately when snow would fall in a location, but we were able to tailor the solution that it monitors now the clouds 24 hours in advance. So it connects to Apple and a couple of other weather stations that map cloud movement. And now what we're able to do is, if at 6 p.m. at night we have less than 75% of the battery charge, we will actually top it up quickly, off peak, cheaply, to ensure we have enough for inclement days. So it's been an interesting test using different batteries, and we are still with lithium iron phosphate, LiFePO4. We are looking to test vanadium redox flow. That is our next prototype to be run. But for the cost of the lithium ion batteries and the availability of them, and obviously the newer versions without any thermal runaway or risk of fire, it's been very successful for us so far. Touch wood.
I'll touch wood here as well.
Yeah.
So, and obviously, with that said, then have you got any kind of examples of any major kind of downtime you've experienced for any particular cases in terms of energy, and how you've overcome those?
So yeah, fortunately, I can't give you an example. We haven't had any. So what we have had is that, if you ask me honestly, I think the solar technology is pretty average. Even for enterprise, the solar inverters are pretty average. So even though we have redundancy across the inverters, we have had inverters fail. I mean, we've had a couple of batteries go DOA as well. But really the issue is they say they're commercial grade, but I still call them residential. And we've used enterprise inverters because we're what we're classed as an island in Australia. And that means the power we generate and the power we store on batteries cannot be exported to the grid. So we have a no export rule. And the reason for that is, if there is a line outage and we are energizing the grid, we can recharge the other side of the downed line and effectively risk of harm. So the island batteries, the off-grid inverters we've used, I just haven't found them. I haven't found one yet that I would roll out consistently. We have 7 different types at 7 different locations, and they're all operating, but each one has its own little thing that doesn't quite work for us, but they obviously are suitable and fit for purpose. And they've given us the redundancy we need. But I think solar, like batteries, has a long way to go, especially when you're talking about enterprise workloads. And one of the funniest things is that our very first customer came up to us and they said, "Oh, look, we think this is wonderful. Solar, that's really, crossing the boundary. And how have other customers thought about it?" And we've said, "Look, everybody have embraced it." And he went, "Well, that's great. Can we just have utility and generator, please?" So our very first customer didn't even want purely green solar power just because it was too new. So there's learnings to be made. But now, Grafton has been online successfully now for just over 2 years on 100% solar power. It's been a really significant milestone for us.
Fantastic. I'm sure you'll see a lot more customers wanting to go online, sustainable native, I guess you would call it.
Agreed.
Fantastic. Okay, I'm going to want to talk about a point, or just quickly, I want to remind our audience again that if you have any questions, feel free to send them through via the app, and I can get onto them as soon as possible. But just quickly, what are the potential implications of edge computing for security and privacy?
So I think that this is the next iteration, with cyber being one of the biggest threats generally now. You're looking at, and Michael Dell said this, if you just look at your IoT devices, and one of the biggest ever attacks one of the biggest ever DDoS attacks was from a camera system that was Wi-Fi enabled or hardwired, and they access the camera system and they use the IoT device, the end camera, to then send packets through the internet at a particular source. So there were 10 billion IoT devices in 2021. There was only 6 billion people. So if you extrapolate that to being triple, quadruple in the next 3 years, we'll be at 30, 40 billion devices, because everything now is getting extra sensors, because we're all becoming used to having the extra information. That the level of security to protect these devices is going to have to be a new version again. You know, the amount of investment into cyber for edge, cyber for IoT, cyber for corporations, the budgets are now, you know, huge. And I think that's realistically an area that will have its own ecosystem. It will have its own vendors. And some of those vendors I don't even think exist yet. I think, you know, if we reflect in 5 years' time, we'll be using names that we aren't even aware of today. So the edge will bring its own new ecosystem of customers and support, because, again, going back to the chicken and the edge, a lot of the things we need to do, we need to have the problem, to understand the problem, to resolve the problem. Because the edge isn't really edgy yet, it's coming, and we're building it, but we ourselves have learned problems about running autonomous sites. You know, we've got 5 locations in Australia that run purely autonomously. There's no human there at all. And that just alone, managing that and managing your customers' expectations is an interesting part. So we ourselves have to use third-party companies to connect to them for cameras, for access control, etc. And then we have to have our own level of security that we ensure that those systems can't be compromised and somebody could unlock one. So it's something that's at the forefront of our mind. And I think there's still a lot of work to go into what will secure the edge or IoT.
Sure. And are there any kind of variable challenges that you would see, you know, from different geographies, for example?
We could go on for a day about this topic. I think, you know, if you look at, we're in 8 different countries. Each country has just its own simple privacy laws. So you've got your variants of GDPR. So in Thailand, any data that's produced in Thailand must remain in Thailand. Any billing, so your billing system, if you bill a customer, all the information of the customer and the billing system must be in Thailand. So you can't transfer any of the data, and you have to prove that your billing system in Thailand. So now you're a global corporation, but it has 8 different head offices. It has 8 different billing systems. It has 8 different privacy laws, has 8 different cyber laws. The term co-location varies in 3 of the Asian countries. And, you know, the other biggest, or the next biggest thing is your traffic profile. If you're in Australia, you know, you're 70, or you might be 70% international, 30% domestic. In Thailand, you're 90% domestic and 10% international, just because it's the Thai language is really only read by Thais. So a lot of the traffic is domestic. So traffic patterns, cost of bandwidth, laws, legals, approvals, and licensing has been an interesting challenge in them all. But what is common is that all the government agencies we've worked with to get these approvals support the digital infrastructure in regional areas where it wasn't. So I think they're very understanding and very welcoming to the edge, albeit we are a foreign company that's obviously doing business in most of these locations.
Sure. I was just going to say, maybe it'd be a bit cheeky to get our production teams to put hashtag chicken and egg at the bottom of the screen, but I'm not sure they'll do that for me. We'll see what happens. But no, and I've got another question through from the audience. So just rephrase that. So how are you carrying out heat load testing and generator testing when you deploy an edge data center?
So our commissioning, UAT and FAT are the same as any obviously facility. So we have a chief engineer, Rob, that runs all of our commissioning processes. So we have two different types of facility. One that's internal, so we will build. So they're all again, I'll exclude America at this point. The edge facilities we built in Australia and Asia are all identical. Half are containerized, and that's a module we have built ourselves to our own spec. So it is fully tested, goes through full UAT and FAT before it even leaves the yard. So we know that the facility is operational and that all functions do work as per design. Then when it lands and it's put into position and the power's terminated, utility on board, we go through a normal series of on-site testing and load testing of the facilities using heat loads in the racks with our own generator and the actual facilities cooling unit itself. All of our containers, what we call the V6 module, are Uptime Institute tier ready, tier 3 certified.
And is that a module that perhaps you could maybe scale further, for say a larger data center application? Is that how that would work?
So it's an interesting point, because if I go back a bit where I said, the edge isn't one, it's many. So whereas a campus, like a hyperscale campus, and again, going back to Scala, he's done an amazing work. I love what he's done there. They have a 600 megawatt campus. What we would do is we would have a small, because again, these are regional areas or they're edge areas. They're further away from the hyperscales. You might end up with 10 modules. We wouldn't put them together. We would geographically spread them around. So if you think about, the spokes on a wheel, the hub being the hyperscaler, and then the spokes going out to the rim, each one of those spokes is a smaller facility. So we would have geographically diverse facilities, which are all interconnected, which allows the workloads, again, to be geographically separated, physically campus separated, and then network segregation as well. So we're trying to keep the facilities apart from each other up until, and there are, again, there's a few variations to this. Thailand, Chiang Mai has the space for 2. Vietnam has space for 2, but 2 is max. We couldn't do any more than 2 modules at those locations, as that wasn't, the crux of the design initially.
Of course, yeah. I'm just looking back through my questions quickly to see if I've had any more come through. No, okay. Okay. So I've got another question here, actually, that was written down just before this session. What are the challenges associated with implementing edge computing, both from a technological and organizational perspective? It's quite a long one. And how can stakeholders help overcome these?
So the first challenge you have is the countrywide one. So again, some countries don't allow import of certain items, or you have to declare certain items, and they're taxed again at a different standard. So there's additional costs involved if you start deploying equipment in new locations. What we found in some of the locations is we would test the equipment firstly in Australia, and then we'd ship it. And then we couldn't ship it because it was classed as used, even though it's brand new. It had gone through its commissioning, its setup, its config. We would ship it. It was classed as used, so we weren't allowed to ship it. So the biggest curve for us has been how to deploy technology into countries where they aren't used to such large or variant amounts of compute and storage coming through. That's been our first part. And then it's obviously it's like, I don't know, it's like imagine going to paint a house and being told you had to pick a color and then seeing the Dulux catalog of 1,000. Every single customer's requirement so far has been, there's no correlation, there's no similarity. I don't have one customer that's doing the same as another. And, we've got 700 customers now, all doing 700 different things, all which are partial edge or related to. So if you imagine right now, this is the early days of I won't use say ChatGPT, but of an AI learning engine where we're just looking at what the consumers and the customers do, what the customers are doing, and then we're trying to map what is our best hardware. So we have 8 locations, and right now we're running 5 different clouds. And it's not because we're trying to overcomplicate our lives. We're just seeing which type of cloud works best. And we're also picking clouds which have all the staff in those regions have the ability to operate and maintain. Because obviously, if you go and deploy a new cloud of a certain technology and you can't get that capability in country, then your cloud will evaporate.
Of course, yeah. And I suppose like you mentioned there, you've got a supply chain element there as well in terms of effectively writing off your hardware before you even get it to site. How are you kind of I suppose you're localizing your sourcing of hardware? Is that correct?
Yeah, so the US massive market, it's been very easy to procure hardware. Same in Australia. The hardware choices in Asia are a lot simpler. There's not as many brands and manufacturers. And again, going past the hardware at the software layer, going back to that support model where Asia's predominantly VMware supported, because that's the simplest and most used. Whereas in America, we've got ONAP, VMware, OpenStack, and a few others. Whereas in Australia, we're using ONAP, VMware, KVM, and Proxmox. So we've got a variety of flavors in different locations. And what the idea is we may end up with a multi-language cloud, which we're okay with because we have the capability internally. But it's a multi-language cloud that we will then, those three, and it's looking like 3 different types of cloud, we will deploy then globally across all of our locations.
And are there any kind of cost implications there in terms of supporting localized hardware?
No. So that, as I said, because the hardware becomes, I won't say irrelevant, but it's easier to standardize on the hardware once you can run the operating system on top. What is important is that we have a global support team now. Look at, we've only been going 2 years, and when we had Grafton, there was 2 of us, and now we've got almost 50 staff across the US. We've just taken on, obviously, the staff today. So we'll have a complement of about 100 people by the end of the year. That's a large complement to look after and be able to support these environments. And we're obviously follow the sun now as well. So, from Australia into Asia, into East Coast and West Coast of America, we have 24-hour coverage, which is obviously, again, something we need considering the amount of locations we have and the unmanned ones. We need, eyes on glass all the time.
Of course, I'm going to kind of, I want to get a picture of what you expect the future to look like. So I guess I'm going to probably make up a word here, but what does an edgified infrastructure look like for the future?
So I'll put all those little caveats in, those little asterisks that says, from Jon Eaves' opinion, this is just my own opinion. I see the beginning of the edge being this year, and a lot more providers becoming edge-ified. What we are doing is, in the US, is obviously a very large growth, and we have a further 17 sites to deploy in the next 20 months, which we will do, and we're on track to do. So for me, this is a platform that spans from Australia into Asia, into the Americas, covering off the entire Asia-Pac USA market of interconnected edge facilities, where your customer can have a workload in many geographies that can be run by a hyperscaler or by an enterprise international. So for me, the edge is mainly right now about the software network layer, which I think is what will power the edge moving forward. The infrastructure will just become a variance from whether it being attached to a tower, a modular data center, or a full-scale data center. So for me, the edge is this next layer of software engineering that comes into mapping across multiple locations, and obviously allowing these workloads to move seamlessly between them to give these low latency, application functions.
Sure. And obviously you mentioned there kind of the number of data centers you hope to deploy over the next 20 months, you said. How, what are the other hurdles that are going to play sort of as factors into that expansion?
Approvals, really. It's approvals. We're in the US now, and what we have, each of the facilities we're building is in a different state. So we have 20 states with 20 councils and 20 city districts and 20 different fire departments with 20 electrical codes, that every single one is I mean, we call them states. I would, from my aspect, it's as challenging as it was between Vietnam and Thailand. So I call them countries. That's the biggest part for us, is obtaining those. Obviously, some of these facilities we've acquired. We have acquired 5 companies this month, which we haven't announced yet. So we will announce the other 4 companies, 1 a week for the next 4 weeks, as we've continued to grow by either acquisition of land or by acquisition of facility.
Sure. I'm not sure if you were able to watch Matt's session earlier, but he mentioned a lot about acquisition in terms of that being the main trend in data center. But is that something you think you're going to see more as time goes on?
I think so. I mean, I was at a conference last year and they called it the Great Convergence. It's where, there's these critical mass of infrastructure players. And obviously what caught a lot of the rich and large funds out in COVID was that they'd backed hotels, student accommodation, commercial real estate, and their values, tumbled to 25%. So these big pension funds, superannuation, all these, teachers funds, union funds, they all want to divest now, I think, or starting to divest a little into digital infrastructure. And obviously the incumbents, the billion-dollar enterprises, they're too hard to get into. The hyperscalers that's a captured market. So I think there's new money will come into this now to enable the smaller players like ourselves to grow to a size where we can become effective as a large entity, effectively to a point where you are a billion-dollar company.
Of course, yeah. I think we're getting towards the end, but I've got another question from the audience, actually from Jeff. I don't know what Jeff's surname is, but we have Jeff asking us this question. So will edge-based cloud services reach the same level of API support and demand that has been reached with hyperscale cloud options? #chicken or edge.
So I'll simplify this with a description I did to my father-in-law, and hopefully this will answer the question to Jeff. He said, what's the difference between edge and a hyperscaler? And I said, okay, so think of the edge as I'm not sure where Jeff's based, but if Jeff's in the UK, if you think of it as Morrison's or Sainsbury's as a large or an Asda, a large supermarket. And then there's your corner stores. Now, corner store is edge. There's a lot more of them. They're a lot closer to your house. They don't sell as much, but you still get the same effect. So a bit like we will offer the important API services that the hyperscalers do, but we will never offer the amount of flavors and varieties of stories that they can, because we don't have the customer base to be able to consume that much or predict what that customer base is doing. So ours is very much a use case based system, but yes, there will be APIs available for them to connect through to.
Fantastic. I think that's a great point to end on there. We've got the chicken or edge.
Finally, thank you.
I was hoping our video production team would put it on the screen somewhere, but no, thank you very much for your time. It's been great chatting to you.
No, thank you. Cheers.